Hello everyone, Professor Vaibhav Shah here. Hope you have checked my previous lectures. If not, I insist you to go through that lectures first, which are containing basics of scales, types of scales, representative fraction or RF, way to solve examples with some useful solve examples. In today's lecture 3, we will be solving some more examples based on concepts and tricks learned from previous sessions. If you like my content and teaching style, then share it with your friends and do not forget to like and subscribe to show your love and support. Let us start. So we'll be using following formulas for the calculation in this topic. So formula number 1, representative factor or RF. RF equal to dimension of drawing upon dimension of an object. If your dimension is specified in terms of length, so it would be length of drawing upon actual length. Now, if your dimension is specified in terms of area, then it would be under root of area of drawing upon actual area of an object. And if it is specified in volume, so it would be cube root of volume as per the drawing upon actual volume. Now, next, we'll be using one more formula, length of scale equal to RF into maximum length to be measured. So here RF, you can get it from the previous equation of RF. Maximum length to be measured, you can have it from your example statement itself. In each of the example, maximum length must be given. And after that, you will be finding this length of scale. So you'll be using this length of scale to draw our actual drawing in your drawing sheet. So this will be your actual length of scale, which we will be drawing in our drawing sheet. So you have to remember these two equations and we can solve any of the examples from these equations later on. So now next, unit conversion tables. You have to memorize this table to get a correct idea of the example, each of the examples. So let us understand this table. So these are the values as we know previously. So this is your table, and I think that most of the example will come from this table itself. So let us go through this table quickly. 1000 meters is equal to 1 meter. 100 centimeter is equal to 1 meter. 10 decimeter is equal to 1 meter. 1 decameter is equal to 10 meters. 1 hectometer is equal to 100 meters. 1 kilometer is equal to 1000 meters. 1.609 kilometers is equal to 1 mile. 1 yard is equal to 3 feet. 1 foot is equal to 12 inches. 1 inch is equal to 2.54 centimeters. 1 nautical mile is equal to 1852 meters. 1 meter is equal to 1.0936 yards. Now, it seems too difficult to memorize this table, right? So now, I will give you one shortcut. So we'll understand this staircase. So here we can convert any unit from your kilometers till your millimeters. And for that, we'll be using this staircase. This is known as unit staircase. So here we can convert from kilometers to millimeters. So let us start. If you go up from this base unit, so we have to use 10 and we'll be dividing by 10. And if we go down from this base unit, then we will be multiplying it by 10. So now let us suppose we have to convert 1 kilometers into meter. So now we are here at the top, as you can see this cat. So this cat is sitting on this kilo. That means we are at the 1 kilometer unit. Now we have to convert this kilometer into base unit. So for that, this cat has to go down by 1, 2 and 3 steps. So that means we'll be using 3 steps downward direction. Now each step suppose is containing 10. So now we have to multiply 3 times 10, 10, 10 and 10. Why 3 times we have to multiply? Because here it says that while going down, we have to multiply it by 10. So we have to go down by 3 steps to get this shoe. So now for this kilometer to meter, we'll be going 3 steps down. So we'll be multiplying 10 into 10 into 10. So that means our answer would be 1000 meter. So if you want to convert 1 kilometer into meter, the answer would be 3 steps. You have to descend from this cat position. So you will be having 1000 meter. So you can try and taste for the another units and get a better idea. But I will recommend you just write down this table somewhere and try to memorize this table. And you can get through any example. So now let us start with the first example. A 3.2 centimeter long line represents a length of 4 meters. Extend this line to measure lengths up to 25 meters and show on it units of meters and 5 meters and show the length of 17 meters on the line. So here 3.5 centimeter long line represents 4 meters. That means the scale is given. So we have to convert this scale into RF first. Extend this line to measure length up to 25 meters, means maximum length we have to measure is up to 25 meters. And we have to show on the scale units of meters and 5 meters. We'll see later on what does it mean. And show the length of 17 meters on this scale. That means after drawing this scale, we'll be showing 17 meters on the same scale. So now let us first start with the RF. So RF we will be using, RF is equal to dimension of object in drawing to the actual dimension of the object. So dimension represents length on the drawing. So 3.2 centimeter long line represents 4 meters. So now 3.2 centimeter is your dimension of object in drawing. So 3.2 centimeter upon your actual dimension of your drawing is your 4 meters. So it is actual dimension of your object. So we'll be converting into a lowest unit, which is centimeters. We'll be trying to convert this meter into centimeter. So now 1 meter is equal to 100 centimeter. So we will convert this meter into centimeter by multiplying it by 100. So it is 4 into 100 centimeters. So after solving this example, we'll be having 1 by 125, which is nothing but our representative factor. Now we have to measure up to the 25 meters. So now our maximum length would be 25 meters. So let us find out actual length of scale, which is ALS, RF into maximum length to be measured. So now RF is equal to 1 by 125 as we have derived previously, and maximum length we have to measure 25 meters. So put 25 meters. Now as we have to use the centimeters only, so we have converted meters into centimeters because 1 meter is equal to 100 centimeter. We have to put in the place of meter here 100 centimeters. So now your 25 meters is now in centimeters. Now after solving this, we are having 20 centimeter line. So we have to first draw one line of 20 centimeter length. After that, we have to divide this line into suitable number of equal divisions. Now in case what should be the division? So here it says that our line should measure in sub units of the divisions of meter, and in primary scale line should measure in the interval of 5 meters. So now if we have to measure the interval of 5 meters, so now here we have drawn line of 25 meters. So now if your line is of 25 meters, that means if you want to measure in interval of 5 meters, then you must divide this line into 5 equal parts. So we have divided this line, 20 centimeter line, into 5 equal parts. So if you can't divide this line into 5 equal parts, we'll be using this triangle method. And after drawing this triangle method, we have divided this line into 5 equal parts. 1, 2, 3, 4, and 5. After this, we will start giving numbering. So we'll start numbering from first division's last part. So we'll be start numbering from here as 0, then 5, because we are drawing the meters in the intervals of 5 meters. So 0, 5, then 5 and 5, 10, 10 and 5, 15 and 15 and 5, 20. So we can see we'll be having one division less than your 25. So this is your 20. Why this is 20? Because this each part represents 5 meters. So this is your 5 meter, this is 5, this is 5, this is 5. So totally we are having total 25, but we are omitting this first division. We are starting this 0 from the end of this first division. So that means this represents your another 5 units. So if we try to measure the complete length, it would be 25, but since we are omitting this first division, so we'll be having this last division as 20. So now this is your 5 meters. Now this also represents your 5 meters, but we'll further divide this division into sub units. So we can divide this unit into divisions of meters. So we'll be dividing these units into 5 meters into divisions of 1 meter each. So we'll be dividing this portion into 5 number of equal parts. Once again, if we don't know the single division for these 5 division parts, we can use this triangle method to divide this particular line into 5 equal parts. So we have divided this subdivision into 5 number of equal parts, and we have given numbering 1, 3, and 5. So it denotes you a secondary unit. After that, we'll be specifying primary units on this scale. So 0, 5, 10, 15, and 20 are showing meters, and this is also showing meters on the secondary scale. So this is showing meters, but these first meters are showing the divisions in the interval of meters. So 1 meter. So this is the difference of 1 meter, 1 meter, 1 meter, 1 meter, and 1 meter. So total these are representing your 5 meters, and these second units represents the division of interval of 5 meters. So as you can see, 5 meters, 5 meters, 5 meters, and 5 meters. So primary scale you are having units in the difference of 5 meters, and in this you are having difference of 1 meter like it is said. Now after that construction of scale, we have to show 17 meters on the scale. For that, length to be shown 17 meters, which is divided into two parts. 15 meters will be showing on the main scale and 2 meters will be showing on the sub scale. So now let us start. So let us show 15 meters. So 0, 5, 10 and 15 on the main scale. Let us draw one vertical line, and for 2 meters on the sub scale, we'll be taking 0, 1 and 2. So second division on the sub scale, we'll draw 2 meters up. So this will be completely showing 17 meters. So this is the end of your example. So the difference is we have to divide this line into divisions of meters and 5 meters. So this is primary scale is divided into divisions of 5 meters, and the secondary scale is divided into division of 1 meter. Rest is all very clear. So this is the end of your example number 1. Now let us see one more example. 3 centimeter long line represents the length of 4.5 meters. Extend this line to measure up to 30 meters and show on it units of meters and 5 meters like previous example. Show the length of 22 meter on this scale. So here also the scale is given. 3 centimeter long line in drawing represents 4.5 meters. So first of all we have to convert it into RF, and after that we have to measure up to 30 meters, which is our maximum length, and we have to show the units into meters and 5 meters and show the length of 22 meters afterwards drawing the scale. So now let us convert this scale into first RF. So here the given that 3 centimeter represents 4.5 meters, or we can say 450 centimeters. So now hence 1 centimeter will represent 450 divided by 3, that is 150 centimeters. So we have just divided this 3 centimeter by 450 centimeters. So we are having 150 centimeter as your 1 centimeter. Now, so the scale is 1 centimeter is equal to 150 centimeter. So now the RF would be 1 by 150, which is clear. Okay. Now here maximum length is given 30 meters. So we have taken the maximum length is equal to 30 meters. Now actual length of scale would be RF into maximum length. So RF is 1 by 50. We know 1 by 50 into maximum length, which is 30 meters, but we'll be converting this meter into centimeters. So we know that 1 meter is equal to 100 centimeters. So try to put this 1 meter is equal to 100 centimeter here. So we'll be having this equation. After solving this equation, we'll be having this total length of scale is equal to 20 centimeter. So now we will construct one line of 20 centimeter length. So we have drawn this line of 20 centimeter length. Now next task is you have to divide this line into equal number or suitable number of equal divisions. So how we decide how many numbers? So here it is specified that you have to divide the line such that it should be in the interval of 5 meters. So we have total maximum distance of 30 meters, and if we have interval of 5 meters, then we can know 30 divided by 5. So that means our line must be divided into 6 divisions to have 5 meters interval of this line. So we have divided this line into 6 number of equal parts. So 1, 2, 3, 4, 5 and 6. So you have to divide this line into 6 number of equal parts. Now let us start numbering. So we'll start numbering from the last part of your first division from 0. So this is the last part of your first division. We'll mark it as 0. From 0 on the rightward direction, we'll be defining this meters in interval of 5 meters. So 5 meters, 10 meters, 15 meters, 20 meters and 25 meters. As we can see, our maximum dimension is of 30 meters, but it is one division less than your 30, which is 25, because we are omitting first division here. So this is also of your 5 meters. So total is your 30 meters. Now let us start subdivision from this 0 on the leftward direction. So this is of 5 meters. Likewise, this is also of 5 meters. Now we have to divide this into interval of meters. So we will have to divide this into interval of meters. So we have to divide into 1 meter each. So 1 meter, 2 meter, 3 meter, 4 meter and 5 meters. So we have total 5 meters of this subdivision. So after that we'll be notifying the units. So this is subdivision meters, this is also meters, and this is RF. So now after that we have to measure the given dimension, show the length of 22 meters on this line. So for that we'll be measuring total of 20 on your primary scale and 2 on your secondary scale. So let us measure from 0. So 0, 5, 10, 15, 20. 20 on your primary scale, and for these 2 we'll be measuring on the secondary scale 0, 1 and 2. So this is your secondary scale 2. You have to draw vertical lines from these 2, and after joining this line you will be having this final answer. So it is a little bit tricky, but always try to understand. We have to show the units of meters and 5 meters. So 5 meters will be using for your primary scale, and meters will be using for your secondary scale. So you have to have the difference of 1 meter on your secondary scale, and you have to have the unit difference of 5 meters on your primary scale. You have to remember that. Like in previous example, it was the same. So now remember, to construct the scale, the data required is first the RF of the scale, second the units which it has to represent like meters, millimeters, centimeters, meters or kilometers in MKS, or inches or feet or yard or miles in FPS. Third, the maximum length which it should measure. If the maximum length is not given, some suitable length can be assumed. Fourth, actual length of the scale to be constructed on drawing sheet. So it can be measured from, it can be found out by this equation. Actual length is equal to RF into maximum length to be measured by the scale. So this is all from my side. Do not forget to share it with your friends and like and subscribe to show your love and support. Keep learning, stay connected, and if you have any doubts or queries, feel free to comment below. Bye-bye.